guys, in this video let me explain non-deterministic finite automata, that is NDFA, or you can abbreviate it as NFA too. So a non-deterministic finite automaton is a 5 tuple Q, sigma, delta, Q0 and F. Here Q is a finite set of states as usual we have defined in case of DFA, and sigma is a finite input alphabet, and Q0 is the initial state that is also in Q, that is Q0 belongs to Q, and also F is a subset of Q, which means you have more than one final states here, so that's why I have used the symbol subset. So F is a subset of Q, that is set of all final states. Next, the transient function delta is a mapping of Q cross sigma to subsets of Q, which means delta is a function from Q cross sigma to 2 per Q. Whereas in case of DFA, delta is a transient function from Q cross sigma to Q. But whereas in case of NFA, only the difference is the transient function. Which means what? Actually, in case of DFA, given the current state, you have only, that is, you have only unique next state. That is, suppose if you are in Q0, by reading input symbol 1, you go to either Q1, Q3, whatever that may be. That means, in the current state, you have a next state should be unique. Okay, but whereas in case of NFA, that is not the case of DFA. It can be of any output. That is, output is not determined. That means there exists more path between one state to other state by reading the same input symbol 0 or 1. For example, in Q0, if you read the input symbol 1 means, so you can have two different states like Q1, Q2, or sometimes 3 too. Okay, Q3, something like that. So which means, so here the next state. So by reading 1, which state you have to choose is that may be chosen at random. Okay, so in an NFA, given the current state, there could be multiple next states. Okay, but whereas in case of DFA, so in the current state, by reading an input symbol, you have a unique next state. That is the difference, main difference between NFA and DFA. The next one, important distinction between deterministic and non-deterministic is as follows. In the case of NDFA, delta of Q comma A, that is a transient function, is a set of states, while in case of finite automata, it is a single state. That's what I have explained previously. So, in case of DFA, you have a unique next state. Unique next state by reading any input alphabet. But whereas in case of NFA, so you have a set of states. Okay, so you have so many possibilities are there. So among them, you have to choose any one of them, right? So next, a string X is said to be accepted by the NDFA, that is non-deterministic finite automaton, if there is some state in both F and delta of Q comma A such that the intersection should not be an empty set. That is, delta of Q comma A intersection F is not equal to empty. That means, as I told already, by reading any input symbol, you have more possibilities. Either you go to Q1, Q2, Q3, Q4 by reading same input symbol, for example 1. So in such cases, you can have more number of states, okay, final states also. By reading an input symbol 2, you can have different possibilities. So in a final state also, you can have more than one final state. If you take the intersection between those two, if it is any one of the final statement, that is accepted. Which means, by reading an input symbol, as that is what we have discussed in case of DFA, this is also the same, but instead of having one path, here there exists more than one path. By reading the string A. Okay, so there exists more path means, so after reading all the symbols in the string, finally if you are at any one of the final state, then that is accepted, or otherwise it is not accepted. Okay, so by reading an input alphabet, at the end of that you are at the final state. Okay, now a transition diagram for the NDFA is shown in the following figure. So this is the transition diagram. So here I have listed out, as I told you already, so it's a 5 tuple Q. What is Q? Set of states. You are having Q0, Q1, Q2, Q3 and Q4. And sigma, that is input alphabet. So here we have only 2 input alphabets, 1 and 0. Q, sigma and delta. So I am going to write down the states here. Next we move on to initial state. So what is the initial state? The arrow label will start indicating this is the initial state. So Q0 is your initial state. That is also one of the state. Okay. So this is the initial state. Next one, final state. So as I told you already, final state is represented by a double circle like this. So we have 2 final states, that is F is nothing but set consists of Q2 and Q4, which means these 2 are the final states. Now let me write down the transition function. So as I told you already, so I am going to write the transition function like this. So input and states. So what are the input symbols here we have? So totally we have 2 input symbols, 0 and 1. So whereas in case of states, so how many states we have? Q0, Q1, Q2, Q3 and Q4. I am going to write it here by reading in state. Initially we are at state Q0. Okay. So initially we are at state Q0. So in Q0, if you read 0, so in 0, if you read 0 in Q0, what are the 2 different paths you have? That is, if you read 0, you have either at Q0 or you move on to Q3. So there are 2 possible states. So in Q0, after reading the input symbol 0, either you can at Q0 or you move on to Q3. Next, for reading 1, so in Q0, if you read 1, what happens? If you read 1, you can be at the same state Q0 or you can move on to the next state Q1. So either you can at the same state or you move on to the next state Q1. So there are 2 different possibilities exist. So this is the only difference between NFA and DFA. Whereas in case of DFA, by reading an input alphabet, you can have only unique next state. Okay, either it may be Q0 or Q3, something like that. But in case of NFA, we can have more possibilities. Okay. Next in Q1, if you read 0, in Q1 if you read 0, no path exists. So you just put pi. Okay. Now no path exists for reading the input symbol 0. Next, in Q1, if you read 1, what happens? In Q1, if you read 1, you go to Q2. So, you go to Q2. Next, in Q2, okay, in Q2, if you read 0, what happens? In Q2, if you read 0, you are at the same state, that is Q2. So, no other possibilities exist, only Q2 alone. In Q2, if you read 1, what happens? You are at the same state, that is Q2 alone. So, no other possibilities exist. 0 and 1 means you are again at the same state. Okay. So, no other path exists. Next, in Q3. So, let me now move on to Q3. In Q3, if you read the symbol 0, what happens? You go to the next state, only one path. So, in Q3, if you read the input symbol 0, what happens? You move on to next state Q4. Next, in Q3, if you read input symbol 1, so no path exists for reading an input symbol 1. So which means empty set pi. Next, in Q4, so this is Q4. In Q4, if you read 0, what happens? So you have again at the same state Q4. So no other path exists. Next, for reading 1, so you are again at the same state. So no other path exists. So only Q4 alone. So this is the transition function. Okay. In some cases we are having more than one possibilities, like 2 states. In some of them we are having empty states. Okay. So like that, you can construct the transition function table for the given NFA. Next, What we are going to do next is, we are going to, for the same diagram here, okay, I'm just write it clearly here. NFA is, here Q is set of state, sigma input alphabet, and F is set of final state, and this is the transition function table. Just now we have write down. Okay, now for the same diagram, what I am going to do here is, so I am going to check whether this NFA accept all strings with either 2 consecutive zeros or 2 consecutive ones. Consecutive means, so these two symbols are juxtaposed, that is nearby. Okay, so here 0 1 0 0 1. Okay, or you can write whatever may be the string you have to taken. So 1 0 1 1 0. So this is also, here you have 1 1 0 means 1 1, again 0 means we are at the final state. So this is also accepted. So like that you can take any string. So that string should consist of 2 consecutive zeros or 2 consecutive ones. Okay, then only that is accepted by this NFA. So now let me take this example. Let me take the string as 0 1 0 0 1 0 1 0 0 1. So now we are going to verify whether the string 0 1 0 0 1 is accepted by this NFA or not. Okay, so for that what we are going to do is, as usual we are at the initial state. Here the initial state is Q0. So now we are at the initial state Q0. So in Q0, what is the first string symbol? So in the string first symbol is 0. So Q0 comma 0. So in Q0 comma 0, as I told you already, so we make use of this transition table. We make use of this transition table. So Q0 comma 0 means Q0, after reading 0 we make use of Q0 Q3, 2 possible states. So here you can write Q0 Q3. Okay, so after reading the symbol 0, so you can have 2 possible states. Either you go to Q3 or you are again at the same state Q0. Okay, next after reading, so 0 over, next we are going to read 1. So if you read 1, what happens, that we are going to see. So while reading 0, so we have 2 possible states, that is Q0 Q3. Now let me check what happens after that if we are going to read 1. Now we are in 2 different states here. So what you are going to do is, you have to write the union of these 2 states using the transition function. So delta of Q0 comma 1 union delta of Q3 comma 1. So now delta of Q0 comma 1, that is Q0 comma 1 means, what is the meaning? So you are at the state Q0 by reading 1. So 2 possible inputs, so leave this 0. So now we are going to read 1. So in Q0, if you read 1, what happens? So in the transition table we have Q0 Q1. Okay, so Q0 Q0, you are in the state Q0, and after reading 1, so you have 2 possible states, that is Q0 Q1. Next you Q3 1. So in Q3, 1, that is, you don't have any other possible states for Q3 for after reading 0 or 1. So that is an empty set. So pi, I just write it here. So these are all the states, we have to take it from the transition table. Okay, so union of any set with the empty set is equal the set itself. So we have Q0 Q1. Next we are going to read, now we read 0 and 1. The next one we are going to read is 0. So while reading 0 1, we are having 2 possible states, Q0 Q1, isn't it? Q0 Q1. So now we are going to read the next symbol 0. So we have 2 different states, so you can write it as a union of transition function. So Q0 0 union delta of Q1 0. Now Q0 0, as I told you already, in state Q0, if you read this input symbol 0, what happens? You have 2 possible states. What are the 2 possible states? Q0 and Q3. And Q1 0. If it is Q1 0 means, what we did already in transition table means, that is empty set. Okay. So Q0 0 means you have 2 possibilities, that is Q0 Q3, whereas delta of Q1 0, that is in state Q1, if you read input symbol 0 means no other possibilities, that is pi, empty set. So the union of any set with the empty set is the set itself. So Q naught Q3. Next one, what you are going to read? In the string we have to read the first three symbols. Next we have to read the next one, that is 0. So while reading the first three symbols 0, 1, 0, so we are at the states either at Q0 or in Q3. We have two different possibilities. Now we are going to read the string 0. So here we have two different states. So we may write it as union of transient function, that is delta of Q0, 0 union delta of Q3, 0. So Q0, 0, as I told you already. So in Q0, if you read 0 means we have two possibilities, that is Q0 and Q3. And Q3, 0. Q3 in 0 means you have only one possibility, Q4. That is from the transient table, I just write it directly, okay. So you can write only Q4 here. Here we have two possible states, that is Q3 and Q0. So if you write it as union means you can write Q0, Q3 and Q4. So this is in order Q0, Q3, Q4. We have three set of possible states after reading the first four input symbols, okay. So Q0 you may either at Q0 or Q3 or Q4. Now after reading the first four symbols of the given string, so we are at the three states. Either we are at Q0 or Q3 or Q4. Now we are going to read the symbol 1. If you are going to read the symbol 1, what happens? You can't directly do like this. So for that you can write it as a union of the transition function. So delta of Q0, 1 union delta of Q3, 1 and delta of Q4, 1, you take it as union. So Q0, 1 means in Q0 while reading 1 you have two possibilities, okay. Q0, Q1 from the transient table, okay. So and Q3, 1 means empty set and Q4, 1 means you have only one possible state, that is Q4. So after reading all these symbols in the given string 0, 1, 0, 0, 1, so you are either at Q0 or Q1 or Q4. So you can be at any one of these states. So now what we are going to do is, as I told already, what is the final state? Here we have two final states. This is F. Okay. So one final state is Q2 and another one is Q4. So here we have two set of final states. So we have to take. So after reading the string 0, 1, 0, 0, 1. So we are at any one of the states Q0, Q1, Q4. So let me take the intersection of these two. So only one of the state is common, that is Q4. Okay. That is one of the final state too. Isn't it? So which means a sequence of transitions leads from the initial state to final state means that string is accepted by the finite automaton, that is NDFA. Okay. So here this string contains a finite state, that is contains a final state Q4. So it is accepted. Okay. That's all. Next one. Consider the state diagram for the machine given as follows. So this is a state diagram for a given machine. So this is the initial state. So arrow labeled start indicates this is an initial state, and we have only one final state here, that is Q4 alone. Okay. Next, here you are having so many possibilities here. Okay. So here the set of states Q is nothing but what are the set of states here? Q0, Q1, Q2, Q3 and Q4. And next one is sigma, the input alphabet. Here we have three input alphabet, that is symbols A, B, C, and delta transient function. The next page I will give you the transient function table for your understanding. As we did in the previous problem, you have to write down the inputs and states and write down the corresponding possibilities for reading any given input symbol, right? So delta and Q0 is the initial state. This is the initial state, and here you have only one final state, that is Q4 is the final state. That's all. So the transient function delta here. Oh, instead of writing like this, you can write like this too in a 5 tuple. This is nothing but Q as because generally we have to write M as Q sigma, Q sigma delta, this is delta, and Q0 F. Okay, Q0 here is your initial state and F is the set of final state. So as in a machine you have to write like this. So like in this order too you can write. Okay, whatever that may be, both are set. Now this is the input and state. Here you have Q0, Q1, Q2, Q3, Q4, and we for 3 input symbols A, B, C. So in Q0, if you read A means you have 2 possible states. That is either you are at the same state Q0 or you move on to the next state Q1. If you read B at Q0 means you are either at the same state Q0 or you can move on to next state Q2. Like that for C. So here the transition table is given. Next, what we are going to do is determine whether the string ACA is accepted by this NFA or not. That is what we are going to do. So for that we make use of this table. Okay, this one we make use of that, and let me check whether that string is accepted by this NFA or not. So as I told you already, a sequence of transition leads from the initial state to final state means that string is definitely accepted by that finite automata, whether it is deterministic or non-deterministic, right? So now for the word ACA, first you have to read the symbol. Initially we are at state Q0. Now we are going to read A, and then we are going to read CA. Now delta of, after reading A, so you have 2 different possibilities, right? So while reading A, so you have 2 possibilities. Either you are at Q0 or at Q1, comma CA. Next, delta of Q0 comma ACA. So here what I am going to do is delta of Q0 comma CA union delta of Q1 comma CA. So that is what we are going to split it here. So one is from Q0 with CA and Q1 with CA. So what I am going to do, delta of Q0 comma C and A. Delta of Q0 comma C and A means you have to split this. Okay. First you have to read C and then A. So first if you read C means in Q0 what happens, you have 2 different states, that is Q0 and Q3. So you just keep A as it is. Now you have to write it as union of 2 transition function, that is delta of Q0 comma A union delta of Q3 comma A. So while reading A in Q0 you have 2 different states, that is Q0 Q1, and reading A in Q3 you have only one possible state, that is Q3. If you take union of these you have Q0 Q1 Q3, that is Q0 comma CA. So Q0 comma CA, this one over. Okay. Next we have to calculate what is Q1 comma CA, this one. Okay, we calculated this one. So now you calculate this one. So Q1 comma CA. So the same process. So Q1 comma C comma A. So in Q1 comma C, okay, in Q1 comma C you have only one possible state, that is Q1 alone. So Q1 comma A. So in Q1 if you read A, you have 2 possible states, Q1 and Q4, right? This is from the transition table. I have to write down directly. So look at the transition table for your clear understanding. So now we have Q1 CA is Q0 Q1 Q3 and Q1 CA is nothing but Q1 Q4. So we may combine these two, that is take union, that is Q0 Q1 Q3 Q4. As I told you already, Q4 is one of the final state, right? So let me take the intersection of this string path along with, that is we are having so many states like Q1, Q0, Q1, Q3, Q4. That is after reading the symbol ACA we have 4 possibilities. Either we are at Q0 or Q1 or Q3 or Q4. Here Q4 is only the final state. Okay. If that is included means that string is accepted. Okay. So Q4 is only the final state. If you take the intersection, what happens? Q4 is the final state that exists. So that is not an empty set, which means that string is accepted. So ACA is accepted by the NDFA. That's all. So in my next video, I will explain how to convert NFA to DFA along with some examples. Thanks for watching. If you like my video, subscribe my channel for more videos. Thank you.